Hello students, let's start the third exercise of the third chapter today. Okay, starting from the first question, to find the transpose of each of the given matrix. Let us copy the question first. We know that to calculate a transpose, we simply have to convert rows into columns and columns into rows. Like for example, in the first part, just a moment. In the first part, we have one column and three rows, right? So we simply have to convert this column into rows. So when we write down each element in the form of rows, it will become 5, 1 by 2 and minus 1. So this is the transpose of given matrix. If this is matrix A, then this will become the transpose of matrix A. Okay, let us write down this in the proper way. Okay, so first part, let us assume this to be matrix A, 5, 1 by 2 and minus 1. So the transpose of matrix A, that is A transpose, will be, let me write it down here, A transpose will be 5, half and minus 1, in which we have one row and three columns. Let's solve the second part. Let the given matrix be matrix B, 1, 2, minus 1 and 3. So to calculate the transpose, first row, that is this one, first row will become first column. Okay, so that will be 1, minus 1, and second row, that is this one, will become second column, that is 2 and 3, right? Let us do third part. Let the given matrix be matrix 3, minus 1, root 3, 2, 5, 5, 3, 6, 6, minus 1. So repeating the same technique, we'll get C transpose is equal to minus 1, 5, 6, root 3, 5, 6 and 2, 3, minus 1. Here we complete the first question. Let us jump to the next question. That is question number 2. We are given two matrices A and B and some equations we need to verify. Let us solve this question. And see, left hand side of this equation, first part, we can calculate easily by adding up the matrices and getting its transpose. For right hand side, you need to calculate their transpose first. So let us solve right hand side first. We are given A matrix, so we can directly calculate transpose of matrix A. That will be minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. Just reversing the rows and columns. Okay. And same way, B transpose will be minus 4, 1, minus 5, 1, 2, 0 and 1, 3, 1. Okay. Let's calculate left hand side first. Left hand side is equal to matrix A plus matrix B transpose. Okay, so that will be equal to, first let us calculate matrix A and B first. After that we'll make its transpose. Okay, so instead of directly solving LHS, let us find it first. A plus B is equal to minus 1, 5, minus 2. We are writing the value of matrix A here and we'll add it to the matrix B now. For the LHS side, we need to first calculate the addition and then we'll do its transpose. Whereas for the right hand side, first we'll transpose it and then we'll add it. There is a difference between the two. Okay. So on addition, we'll get minus 5, 3, minus 2. Matrices add करने के numericals आप last class में कर चुके हो. If you have any doubt, you can go there and watch the previous video. The link to the previous video is provided at the top, so you can click that. Okay. So this is our matrix A plus B. Okay. And we need to calculate their transpose first. So, just a moment. Let us take this to the next page. Okay. So, LHS, that is A plus B transpose, is equal to the transpose of this matrix. Right now I'm copying the matrix and will add a transpose sign here. So this will give me the resultant matrix. It says minus 5, 3, minus 2, 6, 9, 9. I've calculated the transpose here. Okay. And just a moment. Let's go back and copy these matrices and we'll paste it on the next page. Okay, making use of it, we'll calculate the right hand side, that is equal to matrix A transpose plus matrix B transpose, that is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1, plus minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. So addition of these matrices will give me minus 5, 3, minus 2, 6, 9, 9, and minus 1, 4, 2. So we can see that the LHS side is equal to RHS side. Hence A plus B transpose is equal to A transpose plus B transpose. Hence proved. Okay, let us jump to the next question. So we have one more part here. Sorry. That is A minus B transpose is equal to A transpose minus B transpose. So let us calculate A minus B matrix also here. A minus B, that is equal to minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. Subtract minus 4, 1, 1, 1, 2, 3, minus 5, 0, and 1. This will result in minus 5, 4, it is 3, 4, minus 3, then 1, 5, minus 2, 8, 9, 0. Okay, so LHS, which is equal to A minus B transpose is equal to the transpose of this calculated matrix. I'm writing here. Okay, need to calculate the transpose of this, which is equal to 3, 1, 8, 4, 5, 9, minus 3, minus 2, 0, right? And the RHS side we need here is A transpose minus B transpose. Okay. So this is equal to minus 1, 2, 3, 5, 7, 9. This is A transpose matrix minus 2, 1, 1 minus B transpose matrix, which is equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Subtracting this, we'll get down. This is 3, 4, 3, 1, 8, 4, 5, 9, minus 3, minus 2, 0. Okay, so we can check it here that LHS side, which is equal to this, is equal to the right hand side. So we can say that A minus B matrix transpose is equal to A transpose minus B transpose. Hence proved. Now we can jump to the next question. That is question number 3. There is also the same question, same type of question. Okay, so here we have given A transpose matrix and B matrix. So we don't have matrix A here and we don't have matrix A transpose. So let's calculate those two matrices first. Matrix A will be 3, 4, minus 1, 2 and 0, 1. And matrix B transpose would be minus 1, 1, 2, 2, 1, 3. Okay. So for the first part, let us calculate A plus B matrix first. That is 3, 4, minus 1, 2, 0, 1 plus B matrix, which is given here. Minus 1, 1, 2, 2, 1, 3. So this is equal to 2, 5, 1, 4, 1, 4. Right? Okay. So let's calculate LHS first, which is equal to the transpose of this A plus B matrix. So this is equal to the transpose of this matrix we have calculated just now. 2, 5, 1, 4, 1, 4. And for the RHS we have A transpose plus B transpose. That is equal to 3 minus 1, 2, 4, 4, 2, 1 is added to B transpose, that is minus 1, 2, 1, 1, 2, 3. This comes out to be 2, 5, 1, 4, 1, 4. So you can see that these two matrices are equal here, that is LHS equal to RHS, or we can say A plus B whole transpose is equal to A transpose plus B transpose. Now let us solve the second part. Okay, I've just imported the values from the previous page. So for the second part, I need to calculate LHS, which is equal to A minus B transpose. So let us calculate A minus B matrix first. This is 3, 4, minus 1, 2, 0, 1, minus matrix B, that is minus 1, 1, 2, 2, 1, 3. This is equal to 4, 3, minus 3, 0, minus 1, minus 2. Right? Okay. LHS, this is equal to the transpose of this calculated matrix. That is 4, 3, minus 3, 0, minus 1, minus 2, which comes out to be 4, 3, minus 3, 0, minus 1, minus 2. And RHS, which is equal to the subtraction of the transpose of two matrices. So 3, minus 1, 0, 4, 2, 1, minus 1, 2, 1, 1, 2, 3. This is the B transpose matrix here. So the final answer would be 1, 4, 3, minus 3, 0, minus 1, minus 2. So we can see here that both the matrices are equal. So that is LHS is equal to RHS, or we can say A minus B transpose is equal to A transpose minus B transpose. Hence proved. Let us jump to the next question. Question number 4. Just a similar type of question. We are given two matrices A transpose and B, and the values we need to find, there we have matrix A and matrix B. So let us calculate matrix A first, which is the transpose of A transpose. Okay, that is minus 2, 1, 3, 2. Transpose of this matrix, that comes out to be minus 2, 3, 1, 2. So this is matrix A. Okay, and matrix B is given to us as minus 1, 1, 0, 2. This is given to us. Okay, we need to find A plus 2B transpose. So that is A plus 2B. Just a moment. For the better presentation, let us assume matrix C is equal to A plus 2B. Okay. This comes out to be minus 2, 3, 1, 2 plus 2 times of matrix B, that is minus 1, 1, 0, 2, minus 2, 3, 1, 2 plus minus 2, 2, 0, 4. This comes out to be minus 4, 1, 5, 6. Okay, so we were asked to calculate the transpose of this matrix, that is A plus 2B whole transpose, or we can say C transpose, which is the transpose of this calculated matrix, and is equal to minus 4, 1, 5, 6. So this is our resultant answer, required answer. Hope the question is clear to you. Let us jump to the next question. That is question number 5. Okay. We have the given matrix A and B in each part, and we need to verify this required equation. Okay. So let us calculate their transpose first before solving or proving any equation. A transpose is equal to 1, minus 4, 3, and B transpose is equal to minus 1, 2, 1. Okay. Let matrix C be equal to A dot B, product of AB, that is 1 minus 4, 3 multiplied by minus 1, 2, 1. Okay. We'll get minus 1, 2, 1, then 4 minus 8 minus 4 minus 3, 6 and 3. Right. Therefore, C transpose is equal to the transpose of this calculated matrix, which comes out to be minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6 and 3. Right. This is our LHS. So let us write down LHS here. And for RHS we have A transpose, B transpose multiply A transpose. Minus 1, 2, 1, 1 minus 4, 3. This comes out to be minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. So we can see that this LHS is equal to RHS. Right? So we can say that for the given matrix we have A, B transpose is equal to B transpose, A transpose. This was our first part. Let us solve the next part. Okay. Again, before solving this, let us calculate their transpose matrix 0, 1, 2, and B transpose is equal to 1, 5, 7. Okay. Let us assume a D matrix which is equal to the product of the two matrix A dot B. That comes out to be 0, 1, 2, 1, 5, 7. The final resultant matrix would be 0, 0, 0, 1, 5, 7, 2, 10, 14. Okay, so LHS was AB whole transpose, which is equal to D transpose. That comes out to be 0, 0, 0, 1, 5, 7, 2, 10, 14. Right? And for the RHS, we need to calculate B transpose multiplied by A transpose. That is equal to the product of these two matrices, which comes out to be 0, 1, 2, 0, 5, 10, 0, 7, 14. So we can see that these two matrices are equal, or we can say LHS is equal to RHS. Hence, we can write down as AB transpose is equal to B transpose, A transpose. Hence, proved. Let us solve our next question. That is question number 6. We have to solve each part one by one. Okay. So, for A given matrix, we have to prove that A transpose into A is equal to the identity matrix. Okay, so let us solve first part. Let's calculate A transpose matrix, which is equal to cos alpha minus sin alpha into cos alpha. Right? Now LHS, which is equal to product of A transpose and A matrix, this is cos alpha minus sin alpha cos alpha multiplied by cos alpha sin alpha minus sin alpha into cos alpha. So the product will give us cos square alpha plus sin square alpha. Then cos alpha, let us calculate the second element here. Okay. Sin alpha cos alpha minus cos alpha sin alpha. Okay. This will be cos alpha sin alpha minus sin alpha cos alpha, and this is sin square alpha plus cos square alpha. So from the equation of the 10th class, we know that cos square alpha plus sin square alpha is equal to 1, and here they will cancel out each other. This will also cancel out each other, so we'll get 0, 0, 1. This is an identity matrix of the order 2 cross 2, which is equal to the RHS. So we have got LHS is equal to RHS. Hence proved. Let us do the second part now. Again, we'll calculate its transpose matrix first. Sin alpha minus cos alpha sin alpha. Right? To calculate the LHS, we have to calculate the product of A transpose and A, that is equal to sin alpha minus cos alpha sin alpha multiplied by sin alpha cos alpha minus cos alpha sin alpha. This will give us sin square alpha plus cos square alpha, then sin alpha cos alpha minus cos alpha sin alpha. Hope you know how did we calculate this. We have simply multiplied this row with this column to get this value. Okay, and this is cos alpha sin alpha minus sin alpha cos alpha, then cos square alpha plus sin square alpha. The same identity, this is 1, they will cancel out each other, so 0, 0, 1, which is an identity matrix again of order 2 by 2, so which is equal to RHS. So finally we have got LHS is equal to RHS. Let us jump to the next question, that is question number 7. Before doing this question, I hope you know what is a skew matrix, what is a symmetric matrix and skew symmetric matrix. If you don't, then kindly proceed to the session where I have explained that. let us solve the first part. To prove it a symmetric matrix, we have to calculate its transpose. So A transpose will be equal to 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. Okay. And we can observe that A transpose is equal to matrix A. Such matrices in which their transpose is equal to the same matrix, they are called symmetric matrix, right? This we have done. Let us solve the next part. Here we have to show that the given matrix is a skew symmetric matrix. Again, for this also we have to calculate its transpose, which is equal to 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. But we have to take minus 1 common, or we can say we have to multiply each term, each element by minus 1 by placing minus 1 in front of the matrix. ठीक है, एक minus 1 हमने यहाँ पे रख दिया और दूसरे minus 1 को हमने each element के साथ multiply कर दिया. So we got 0, 1, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Okay, so we have got minus of this matrix 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. So we can see this on the right side. We have the same matrix, that is matrix A. So we can write down minus A. Okay. We have seen that transpose of matrix A is equal to the negative of the same matrix. Such a matrix is called a skew symmetric matrix. Okay. Therefore, A is a skew symmetric matrix. Let's jump to the next question. Now we have to do question number 8. Okay. We are given a matrix A here. Okay. We need to calculate its transpose first. So transpose of matrix A is 1, 5, 6, 7. For the first part, we need to calculate matrix A plus A transpose. Let us assume this to be matrix C, which is equal to 1, 6, 5, 7 plus 1, 6, 5, 7, right? And this comes out to be 2, 11, 11, 14. Okay. So calculating the transpose of this matrix C, that is C transpose, 2, 11, 11, 14 transpose, that comes out to be the same 2, 11, 11, 14, which is equal to C. Hence, C is a symmetric matrix because its transpose is coming out to be equal as the matrix. Okay. For the second part, we need to calculate A minus A transpose. Let us assume this to be T, right? This comes out to be 1, 6, 5, 7 minus 1, 5, 6, 7. This comes out to be 0, minus 1, 1, 0. Okay. Calculating the transpose of this matrix D, it is 0, minus 1, 1, 0. Taking the minus common, it will become 0, minus 1, 1, 0, which is equal to the D. So here we have D transpose equal to negative of D. Hence D is a skew symmetric matrix. And in the above part we have transpose of C equal to C matrix. Hence it was symmetric matrix. Okay. Let us solve the next question. That is question number 9. Okay. We have given a matrix A. So to solve the question we need the transpose of this matrix. So let us calculate A transpose first. 0 A B minus A 0 C minus B minus C 0. Right. Let us assume a matrix C equal to A plus A transpose. This comes out to be 0 A B minus A 0 C minus B minus C 0 plus 0 minus A minus B A 0 minus C B C 0. Its sum comes out to be 0 0 0 0 0 0 and 0 0 0. Right? So half of A plus A transpose is equal to half of C, that is half of null matrix, that is equal to null matrix only. Right? Same way we can calculate a matrix D which is equal to A minus A transpose. That comes out to be 0 A B minus A 0 C minus B minus C 0 minus 0 minus A minus B B 0 minus C B C 0. This comes out to be 0 2A 2B. Okay, my mistake. This was A. Okay, this would be minus 2A 0 2C minus 2B minus 2C 0. Okay, calculating the half of this A minus A transpose, that is equal to half of matrix B. This would be half of 0 2A 2B minus 2A 0 2C minus 2B minus 2C 0. This comes out to be 0 A B minus A 0 C minus B C minus C 0. Hope it is clear to you. It was an easy question. Let us jump to the next question. That is question number 10. We'll solve this question one by one. And we have a technique to convert a matrix into the sum of a symmetric and a skew symmetric matrix. So let me tell you the technique first, then we'll solve each part. We'll assume a matrix P which is equal to half of matrix A, which is a given matrix, plus its transpose, and we'll assume another matrix Q which is equal to the half of the difference between the two matrices. Okay. Finally, we can write down matrix A given matrix as the sum of P plus Q, where this P is a symmetric matrix and Q is a skew symmetric matrix. Hence, we'll get a matrix A which is the sum of a symmetric matrix and a skew symmetric matrix. Hope the technique is clear to you. Let us solve our first part. Do remember the technique. Okay. So let this given matrix be matrix A 3 1 5 minus 1. Okay. We'll calculate its transpose matrix. That will be 3 5 1 minus 1. Let a matrix P that is equal to the half of A plus A transpose, that is the half of matrix A 3 1 5 minus 1 plus 3 5 1 minus 1. Okay, this comes out to be half of 6 minus 2, which is equal to 3 3 3 minus 2. Yes, this is a symmetric matrix. You can calculate its transpose, which comes out to be the same. This is a symmetric matrix. Okay. Let another matrix be Q, which is equal to half A minus A transpose. That comes out to be 3 1 5 minus 1 minus 3 5 1 minus 1. This is half 0 4 minus 4 and 0. This comes out to be 0 2 minus 2 0. Right? This is a matrix Q, which is a skew symmetric matrix. Although it is not asked in the question, but still let us verify that we are right. Our answer is correct. Hence, adding P and Q, we will get 3 3 3 minus 2 plus 0 2 minus 2 0, which comes out to be 3 5 1 minus 2. Sorry. Just a moment, I think I have made some mistake here. Oh yes, here it should be minus 1. Okay, so the correct matrix is 3 3 3 minus 1. Okay, so let me correct it here. This is minus 1. Okay, so now I'll get minus 1 here. Hence, it is equal to A. So, the sum of two matrices is equal to the given matrix A. Right? We will not verify it in the further questions. Let us do the next part. Same way, let us assume this to be matrix A 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3, and its transpose will be 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Right? Let P be equal to half of matrix A plus A transpose. I am writing it directly. Okay, we already know how to solve this. be 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is a symmetric matrix. We can observe it. Let another matrix Q be half A minus A transpose, that is equal to 0, again 0, and again 0. Zero, and 0, 0, 0, which is equal to a null matrix, right? And we can easily see that P plus Q is equal to A, or we can write it down as A is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, plus 0, 0, 0, and 0, 0, 0, where this is P and this is Q, right? Let us solve the next part. Let A is equal to 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This implies A transpose will be 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, and 2. Let matrix P is equal to half of A plus A transpose, which is equal to half of, again I am solving it directly, 6, 1, 3, 6, 1, minus 5, 1, minus 4, minus 4, this is minus 5, minus 4, and 4, right, which comes out to be 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, asymmetric matrix, right? And let Q be half of A minus A transpose, which is equal to half 0, 5, 5, and 3, then minus 5, 0, and 6, minus 3, minus 6, and 0, which comes out to be 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. Of course, which is a skew symmetric matrix. Okay, so we can write down our given matrix A as the sum of P and Q. That is 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, 2, added to 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. You can add them and verify if your answer is correct or not. Let us jump to the next part, the last one. Let matrix A is equal to 1 minus 1, 5. and this will give a transpose matrix as 1, 5, minus 1, 2. Let P is equal to half of matrix A plus A transpose, that is half of 2, 4, 4, 4, which is equal to 1, 2, 2, 2. And let Q is equal to half of A minus A transpose, which is equal to half of 0, 6, minus 6, 0, that is equal to 0, 3, minus 3, 0, which is a skew symmetric matrix. So we can write down a given matrix A as the sum of P and Q. And you can verify if your answer is correct or not. Hope you understand this question. Let us do the next question. This is an MCQ based question. If A and B are symmetric matrices of the same order, okay, then AB minus BA is symmetric matrix, zero matrix, and identity matrix. The answer is skew symmetric matrix. Okay. 12th question. If A, this is a given matrix, then A plus A transpose is equal to identity. If the value of alpha is, so let us solve this question. Okay. So let us calculate the transpose of the given matrix first. Cos alpha, sin alpha, minus sin alpha, and cos alpha. Now, as per given in the question, A plus A transpose is equal to identity matrix. So this implies the addition of the two matrices A plus A transpose is, I am writing it directly, 2 cos alpha, adding the first element, then second element is 0, then this is also 0, and this is 2 cos alpha, right? This is equal to the identity matrix, that is 1, 0, 0, 1. Okay. Comparing both the sides, we'll get 2 cos alpha is equal to 1, or we can say cos alpha is equal to 1 by 2, right? This will give cos alpha is equal to cos pi by 3, right? So we'll get alpha is equal to pi by 3. Hence, B part is the correct answer. So here we have completed the third exercise of chapter number